Morning, everyone. Welcome to the SupportDHC webinar on the Toolbox Lounge. I can see that some participants are still joining. At the moment, we have 69 participants, which is very nice, and the number is increasing. So let's start with the webinar. And first of all, I would like to thank Euroheat and Power, who is the organizer of this webinar, as an activity which is part of the SupportDHC project. And Euroheat and Power is leading activities on the replication. And this webinar is one of replication activities that we are implementing in the SupportDHC project. So as the webinar title says, it's a Toolbox Lounge webinar where we will present practical tools for integrating low temperature heat into high temperature district heating networks. So it's much about knowledge presentation to you. And we have 1.5 hours for this knowledge exchange. So we will just start straightforward and dive into the agenda. So as you can see, first of all, we will introduce the SupportDHC project very shortly. And then we will dive into the tools. We will present 6 tools today by different speakers. And at the end of the event, we will have a questions and answers session. So try to keep your questions, if possible, for later, so that we can really present all knowledge to you, because time is very limited per tool, and we have 6 in total. And there is a questions and answers button, which you can see, and there you can place your questions. So yes, having said that, let's dive into the SupportDHC project presentation. So the SupportDHC project is funded under the LIFE program of the EU. And it supports fast implementation of low-grade renewable energy and waste heat for district heating and cooling. So here you can see the project details. We launched the project in 2023, and there is 1 year to go until September 2026. It is around 1.6 million European Commission contribution project, and WIP Renewable Energies is the coordinator of the project. Namely, my colleague Dominic Rutz is the main coordinator of the project. So the objective of the project, it's difficult to place it in several lines. But the project addresses challenges by supporting fast implementation of low-grade renewable energy and waste heat for district heating and cooling in Europe. And it is achieved by supporting district heating and cooling operators in drawing up transformation plans, kicking new activities for them, in particular concrete investment plans for them. So there is much of support of know-how that project offers. Here you can see the focus of our project. We have 6 target countries: Austria, Germany, Italy, Lithuania, Poland, and Ukraine. And there are also front-runner cases. We will not go into the detail of the concept of the project because it's not the scope of this event, but just for you to see who is involved. So yes, the focus you've seen. And here you can see also the front runners in red dots, and also the whole consortium partnership with different organizations and supporting countries, Denmark, Sweden, and of course Euroheat and Power, our main project partner for application activities, also for spreading the know-how and connecting stakeholders. Here is shortly shown the graph of the project concept. So as you see, replication program is very important for our project. That's why webinar is also part of it. There are also different other activities foreseen, and we will mention it later because there is a separate link for the replication hub where you can get familiar with different information and use it. Here you can see the front runner cases. We will also not go into detail because all presentations will be also available after the event for getting more familiar with further details. Well, impact is also worth mentioning. So the project will support 38 district heating and cooling operators. It's also much about the capacity building, knowledge transfer, also improving the regulatory framework, working on some hurdles and doing some analysis, and of course supporting the district heating and cooling sector in Ukraine, and of course reaching out to stakeholders. Well, thank you. That's all about the SupportDHC project in a few slides. And you can reach out to the coordinator for further requests and questions. Then I would like to mention that the SupportDHC Replication Hub has a separate website, and you can see here the QR code, so feel free to scan it already now so that you can have it for later. There is also a link to the website and to the SupportDHC project. So everything is interlinked and made for your convenience. In this replication hub, you will find different tools. And these will be also presented today in our webinar. And so we will now start with the first tool. And it's about transition of district heating systems. And Mr. Daniel Heiler from AGFW will be the speaker for this presentation. He's a senior advisor in the Research and Development Department of AGFW. And just to shortly mention that AGFW is the Energy Efficiency Association for District Heating and Cooling and Combined Heat Power. It's based in Frankfurt am Main in Germany. So, Mr. Daniel Heiler, the floor is yours. We have 10 minutes presentation.
Okay, thanks, Rita, for the introduction. And hi to everybody. And the topic is quite clear now. This is the content. Due to the time, I just go through it very quickly. And the main things in Germany, there are these two major, let's say, laws or things. One is the municipal heat planning, and the second is the district heating transformation planning. The municipal heat planning has to be done by the cities themselves, so by the administrations. And this should be some kind of a guidance for the whole transformation plan to be, let's say, CO2 neutral latest in 2045. And there are two obligations for for the size of the cities, meaning cities with more than 100,000 inhabitants has to present their heat planning by June 2026, while the smaller cities, they have 2 years more time to do that. Then we come to the transformation planning. The district heating transformation planning has to be done by the district heating operators, of course. And most of them, let's say, do it according to the federal funding for efficient heat networks, which is the abbreviations in Germany is BEW. And this is a support program where which I can let's say a little bit more at the end of this report of this performance. And yeah, and just to say, there is another obligation according to which this district heating transformation has to be done, and this is according to the heat planning law part 3. That means that every state in Germany has to approve it, has to approve the heat transformation planning of every, let's say, district heating system in its states. And you can see the last sentence. The transformation planning defined the long-term targets and roadmap and should be revised every 4 years until the system is fully decarbonized. That means that all the transformation plans have to be, let's say, changed and revised every 4 years. This is something very special, but we think that this is the best way to do a transformation planning, because nobody can say what is in 10 or 15 years time from now. So every 4 years it has to be redone, let's call it like that. And there are very special steps for the transformation planning. And let's say there are 5 different things that has to be considered. The first is the actual state of the investigation area. That means that people start not with a whole district heating network, but just with a one part of the district heating network, and then go on with another part. So this is meant by the actual state analysis of the investigation area. Then in this area, all the potential renewable energies and waste heat have to be considered, or has to be looked after. The third thing is the target analysis of the heating network and the generation, meaning what will be the generation in 5 years, in 10 years, or whatever time. The same for the heating network. And the whole path towards the greenhouse neutrality should be described and should be updated every 4 years. And of course, the cost framework should be, let's say, also regarded. The actual state analysis of the investigation area. Now I go a little bit deeper into all these 5 different points. What is the work that has to be done in the individual states, or in the individual times? So first of all, the definition and description of the restricted investigation area, as I already mentioned. Then there should be a description of the client structure, including energy consumption. Client structure means public customer, private customer, or administration, or something like that. And what is also very important is that there should be the real energy consumption. And this can be given by the chimney sweep or by whatever it is, but the energy consumption is very important. Then there should be a description of the existing district heating network, meaning does it has to be, what are the diameters, what is the age of the respective district heating pipes, and so on. Then there should be a description for how to, let's say, change the existing heating facilities, heating generation sites. This is a very crucial point. And if it comes to the assessment of renewable energies, there are some, let's say, there are some potential that has to be looked at. And I don't want to read all these things here, starting from sector coupling, etc. And especially all of these things have to be looked at and have to be investigated. For the first time, there is a crucial but relatively rough but precise enough overview first. And if the first overview is done, then there should be investigated selected potentials in more details. Like, for example, if we go to deep geothermal and there is no deep geothermal possibility, if there is no, let's say, no possibilities to do that, then it is just you just have to say, well, we did a research for district heating, but it's not possible. This is meant by this more detailed overview. Then the target analysis of the heating network and generation. We have here three different aspects. The first is the demand scenarios for heating and cooling, of course, then the heat generation. And when there is written here both transformation plans only relies to existing heating networks, or if there is no district heating at all, then if there are new heating networks, there should be an indication of the increasing indicative shares of renewable energies up to the year 2045. And this there are very special milestones every 5 years to this 2045 year. And the last of this is the heating network temperature reduction, which is in my consideration one of the most difficult things. So, and if we look at all these three aspects, everything has to be checked, and from two different points of views, first from the technical side and then from the economical side. Then, since the reduction of district heating temperatures, network temperatures, it is very crucial that there is a long time reserved for the, let's say, for the customers to replace, for example, some radiators or some things if the district heating temperatures are going to be less than they are actual. And the most important things what we have seen in the past were that there were some problems with heat exchangers and with a respective regulation valve, though this must be a very careful look for these things. Then we come to the transformation plans and cost framework, the path to greenhouse gas neutrality. This is, as I already said, this is a long way to go there, which has to be described every 4 years, have to be made some let's say some view back, what was done, what has to be done, and especially for the heating networks, it must be clear, are there new customers connecting to the district heating network, or will there be some reduction due to efficiency measures like insulating, isolations, and so on. And it makes sense, in our opinion, to divide these measures in these three divisions, starting with the heat customers, then network and heat generation at the end, and to have a timeline. Because let's say if you stick to the point that we have to reduce temperatures, this has to be a very precise timeline, because you have to be clear or to be sure that every customer can cope with these new things. That's why it is very important to have a very precise timeline. Then the cost framework, it is also something we can say the cost framework is, as usual, the comprises the investment costs, the capital costs, and the operation costs. And of course, there should be, let's say, a realistic estimation about the heat price in the future and whether it's economical or not. And yeah, there is a special point for the investments. The investments, for example, in Germany, there are some measures that are without subsidies. They cannot be profitable in these days. So there is really a need for subsidies. So now I come to the point where I describe this this federal this BEW, what is in there. This, roughly speaking, this BEW consists of 4 different modules. Module 1 is the feasibility stage or feasibility study or a transformation plan for existing heating networks, feasibility study for new networks. And there is a subsidy up to 2 million euros or maximum 50%. Subsidy investments module 2. Module 2 is the module where you invest some things, perhaps to new pipelines or a new generation facility. And per module 2, you can get up to 100 million euros or up to 40%. And you need to do the very first one in between 4 years. And the second module 2, you can then go for from the 5th year, and you can get an additional 100 million and so on. Then module 3 is a module for rapid investment, so-called. For example, if you just want to install a big heat pump, you just stick to it and this is enough for me, and you can get here also 1 million euros or up to 40%. So then the last one is module 4. This is an operational subsidy for heat pumps, and depending on the SCOP, so the yearly coefficient of performance, and the second step, it depends on the electricity purchase, whether it's from the electricity grid or it's from renewable energy. Then it makes either 9.2 cents per kilowatt hour or 3 cents per kilowatt hour if the electricity comes from a direct connected renewable energy source. Then for the solar thermal, there is just one, let's say, one type of subsidy, and this is 1 cent per kilowatt hour thermal. And both subsidies, okay, Rita, both subsidies can last for 10 years. Then just a few pictures concerning some figures. This is from the update from the study perspective of district heating sets of measures 2030. There you can see how the quantity and structure of heat generation rises from 124 terawatt hours to 189 terawatt hours in 2045. The installed capacity for heat generation will come up from 47 up to 100 gigawatts. And then sorry, just a little bit back. The investment costs will rise up to 74.4 billion euros. And the amount of subsidies are shown here. From 2030 to 2045, it is for the time being some 53 billion euros. Then just for a few things for planning guidelines, which are done by HEFW. This is the one for this project. This is a regular one for all members of the HEFW, and this is a regular, let's say, rule. It has to be seen like a D norm. And so I come to the end. Thank you very much.
So many thanks for Daniel Heiler, who just presented transition of district heating and cooling systems and the first tool. As mentioned, please feel free to ask questions in the questions and answers platform, because at the end of the event, we will have some time dedicated for discussions. Many thanks, and we will continue with the second tool, which is about mapping of low temperature sources. This tool will be presented by Alex Soren. Energy and sustainable energy planning. with strong expertise in district heating, energy efficiency, and integration of renewables. So, Mr. Alex Sorensen, the floor is yours.
Thank you, Rita, and thank you for the introduction. Good morning, everyone. Yes, the next tools, that's actually the steps in the transition. So the first, as you could see from Daniel's presentation, that is to map the low temperature sources and also other demands. If you go to the homepage in your Heat and Power, you can see these tools, and this is tool number 2. And in tool number 2, it's you can see the address in the top, replication hub.SupportDHC. And the mapping is normally is part of energy planning and heat planning. So actually we go into another toolbox, and that's a heat planning toolbox made by Plan Energy when we want to map the excess heat sources. So if we press in the bottom, then you get the homepage of Plan Energy, and then you can download the heat plan toolbox. And the heat plan toolbox is actually made for Baden-Württemberg a couple of years ago for the heat planning process. And it's an interactive tool. So if you click on it, then you can see what the content is. And one of the steps, first is preparing the ground, then mapping, then scenario analysis, and then plan and implementation. And if you click on mapping, then you will get what you can do on the mapping. And we want to get the excess heat survey. So we go to that, and here you can read pro and cons about mapping of excess heat as a best practice and a worst practice, Danish practices, where you have some bad and good examples. And if you go to more info, template for excess heat survey, then you actually get some possibilities. And there's a slide series mapping, and you open that, and then you have a slide series, what should be heat mapped, how, and by whom. So, and it's about mapping not only of excess heat, but it's also mapping of what you need in such a transformation process. So it's heating use, and it's existing infrastructure, and it's renewable resources. So if you go on, then there's a tool called Hot Maps. It's developed also supported by EU, and it's you could say it's a web tool where you can, if you go into the tool, you can get by web, you can get waste water treatment plants, power and capacity. You can get agricultural residues, forest residues, wind power in 50 meters high, solar radiation, and so on, and geothermal potential. You get a lot of, you could say, the data which are public available via hot maps. But the problem is always, if you want to find out excess heat, then you have to go to the next and say, where do we find that? Well, of course, there are, if you look at the bottom, there are the public data from sewage water, drinking water, and so on. But also, what's interesting, very often that's the industries and other sources. So that can be refineries and all kinds of metal industries, paper production, data centers, and so on. And what's coming up now is also power-to-X production facilities, hydrogen production. So how do we map this kind? Because you cannot find very much in public data. So if you want to utilize excess heat from industries, you could of course try to contact them, and they will very often they will not answer. So you need to have a more, you could say, systematic process. So what our experience in Carnegie is that we use, this is an example from one of the Danish cities, we start with a list of possible industries, and very often there's a commercial part in the municipality where we can find this list. And then we create a cover letter in cooperation with the city, and it's sent to the industries. And there we will mention that somebody of them will be visited and some will be interviewed per telephone. And then we arrange all the interviews and also the questions. You can see the questions here. And we did that. We had done that in more than one municipality, actually 3, 4. And every time the industries are actually very positive because they want to be part of the green transition, but their normal job is to sell the products. It's not to sell heat to the district heating company. So you have to be proactive. So if you look at the result here, we had 7 different industries. It's not a huge industrial area, but there were some factories, and they were all those. They were visited, and we got the power and the temperature and the delta T and which time they had the excess heat. And actually, I think half of those are utilized today. So it's possible and it works. Yeah. That's all from my side.
So many thanks for Mr. Per Alex Sorensen for his hands-on experience on sharing his knowledge on the mapping of low temperature sources. We will continue with the third tool. It's about reducing grid temperatures. And here we will have 2 speakers from Halmstad University. We will have Hendrik Gard, senior lecturer at Halmstad University, and Luis Sanchez Garcia, PhD student at Halmstad University. And just to add that Halmstad University in Sweden combines applied research and education with strong industry collaboration. So the floor is yours. 15 minutes, please.
Thank you, Rita. And hello, everybody. So we have made a tool for estimate the benefit for temperature reductions. I mean, you not only want to be able to invest, you want to know how much you can gain from the investments. And the easiest way to increase profitability in district heatings, that is to decrease the system temperatures. If you have, especially when you go from fossil heat supply to renewable and sustainable, the reduction is very important. And I will start with a short introduction before Luis will present the tool itself. I should say also this tool, the Excel-based tool, is part of a kit where there also is a report available where we describe a little bit more the benefits for temperature reduction and also how to work with decreased temperatures, practically how to prioritize customers to visit to decrease the system temperatures. When we're talking of decreased system, we have both the supply temperature and the return temperature that can be reduced. Very often you refer to it as decreased return temperature. But to be able to decrease the supply temperature, you have to start to decrease the return temperature. And one problem is if you decrease the supply temperature is that the decreased temperature will actually rise if you don't work on the customer side. If we look on benefits, we can see that depending on what system you have, the most important or what is most important to decrease, if it's the supply temperature or return temperature, depends on your system. So you can't say that it's this or that, because on the existing systems, what heat supply you have at the present. And as we can see here, if you decrease the supply temperature, you can increase the industrial excess heat, but we can find that also on return temperature, and that depends on what temperature you have on the excess heat. Then you have the increased output from heat pumps. You have an increased output from or increased heat pump efficiency, and you have increased electric output from CHPs. Less distribution losses, even though the distribution losses is normally very, very, very small part of the profitability to decrease temperatures, even though very often you hear that is an important reason. That is actually a pretty small part of it.
Henrik, could you move on? Okay. Hi, everyone. I'm going to talk now about...
Sorry, I had one thing more, Louise, sorry. Apart from the economical benefit, you have other benefits also. When you work with the decrease the temperatures, you have to visit the customer. And from my own experience, I can tell it gives you a lot better relation with the customers. I mean, you come to customers and help them. You find faults at the customers. And it also gets you a lot better knowledge of your own system. So there are not only economical benefits, there are also other benefits from a business point of view. Sorry, Louise, now it's you.
Thank you, Henrik. I'm going to talk now a bit about the tool features. And first of all, we developed this tool as to provide a quick estimate of the economic benefit of reducing the system temperatures. And when I'm talking about system temperatures, I refer to the supply and return temperature of the district heating. And for key production technologies. And we also wanted to adapt a bit the results to the local climatic conditions, for which the tool downloads automatically data from PVGIS concerning weather and solar radiation. And it's also possible to tailor some economic data concerning each technology. But it's a simple tool made in Excel, so the simulation of each unit is quite simple. It's not an optimization tool that you could probably run in Energy Pro, for example. In this first slide, you can see on the right side the main input of the tool. This input is common to all technologies. And in the first box on the upper right side, you can enter the supply and return temperature for the initial conditions and also for the future conditions when the temperatures have been lowered. In the next box, it's possible to enter the annual energy supply to the district heating system, as well as the share of domestic hot water and space heating and heat losses. And these data are used to estimate hourly profile, which is used for the calculations of each technology. In the next box, you can enter some common economic conditions, such as the interest rate, the electricity price, which is used for the heat pumps and also for the pumping cost of the district heating network, as well as the peak load price. The tool is designed to simulate base load technologies, and when we change the temperatures, the production of each unit may change. So, for example, the production of a solar thermal plant would increase if we reduce the temperature, which means that the peak load will decrease. And we can estimate the impact of this based on the cost of the peak load unit. So a peak load unit is just a generic based model with a generic price. And the last box on the right refers to the geographic data, latitude and longitude. And this is used by the Excel tool to download data, weather data from PVKey's API. This was regarding the common input. On the left, you can see the overall results of the tool. On the first column, you can see the different technologies. And the second column, you can see the heat share. This is the share of heat production provided by each technology. In this case, we have filled in most of the technologies, but in an actual application, you should only fill the technology that you're interested in, because the tool is only designed to simulate one main base technology. For example, an air heat pump that would deliver like 60 or 80% of the heat demand. And next, we can see the output of the tool. And the output is provided on the one hand on the savings on our existing unit. For example, let's imagine that we have a heat pump that was installed. We assume that the investment costs are sunk costs, so we disregard them. And the benefit would only be in operation costs of this heat pump, and also probably reduction of peak load production. However, the tool also provides the benefit of a future unit. Let's imagine that we currently operate a fossil fuel gas boiler and want to switch to a heat pump. Then we could estimate what's the investment reduction and the operation reduction of this future heat pump, assuming that we are able to reduce the temperatures from the current level to a lower level. These costs are given in euros per megawatt hour of heat delivered and degrees centigrade, but also in absolute cost in euros per year, taking into account the annual production of the system. Besides this generic input, it's also possible to introduce more detailed data, although the user can also utilize the default values provided by the tool for the different technologies, which are solar thermal, air heat pump, other heat pump, geothermal, and flue gas condensation. For example, in these solar collectors, we can see that we can introduce different characteristics of the solar collectors, as well as inclination and orientation and investment features. Concerning the air heat pump and the other heat pump, the main difference between these two is that the air heat pump uses the outdoor air temperature to determine the COP in each hour of the year, whereas the other heat pump uses a fixed COP for the entire year. Besides heat production technologies, the tool does take into account tank storage and the possible reduction in pumping costs in district heating network, in case there's an increase in the temperature difference between supply and return. And finally, we can see in this graph the results for the different technologies. And we can see that, for example, for geothermal, the investment reduction is quite significant in case we reduce the temperatures. And also it's quite significant for solar thermal and flue gas condensation for operation. And that's all. Thank you very much for your attention, and we'll be here to answer any questions that you may have.
Many thanks. Thanks to Henry Gard and Luis Sanchez Garcia for presenting the tool on reducing grid temperatures. So we are halfway through. I see 83 participants, which is great. So we continue, and please stay with us. So we will continue with tool 4 about heat pump technology overview. It will be presented by Mr. Per Alex Sorensen from Plan Energy, who also already presented tool 2 today. This will be a short presentation of 5 minutes. Please, Mr. Per Alex Sorensen, the floor is yours.
Yeah, thank you again. And I'll just go to the heat pump description. Again, if you go to the homepage, you can see there are possibilities of downloading an introduction of the tool, and for all the tools there's this introduction, and it's in 6 different languages. And then you can download 2 fact sheets, one on high temperature heat pump and one on, you could say, low temperature heat pump. So if we go to the low temperature heat pumps, it's taken from IEA District Heating and Cooling Annex TS5. And in this project, which was a project how to integrate renewable energy sources into existing district heating and cooling systems, there are 10 fact sheets and actually 5 applications where we combine different technologies. So here you can see the content of the fact sheet. What's interesting in the low temperature heat pump fact sheet is that we use the Lorentz efficiency. And the Lorentz efficiency, you calculate ideal efficiency, and then there's a percentage of the how efficient it is. So this percentage is normally between 50 and 55, and depending on the product. And then we use natural refrigerants. We prefer that. And there's a list of possible suppliers. It's not complete. So if you have ideas, we can update it. And then there are some cases. Use of ambient air in Denmark and drinking water in Italy. For the prices, there are prices from Northern, Middle Europe, Southern Europe, and also other US and Asia, ideally, not always updated, because we didn't get all the facts. But here you can see prices from Northern Europe, and also there's regulation capacity. We'll see how quick can heat pump regulate up and down. If you go to the high temperature heat pump, it's not as systematic, but it's still about natural refrigerants, because in our mind, heat pumps using natural refrigerants are as effective, or even sometimes more effective than other refrigerants. So why use anything else than natural refrigerants? And that can be water vapor, hydrocarbons, ammonia, and water, and CO2. And we have some examples. We have taken out, for instance, now the MAN has got another name, which I cannot spell, so I still have MAN. Here you can see some facts about the heat pumps. Smallest unit is 12 megawatt and so on, and then some advantages and disadvantages. And that's for all the 4 types of heat pump. There's such an example. So that was all. You can look at it yourself.
Many thanks for Mr. Alex Sorensen for the short presentation. And we will continue with the next tool about the pre-feasibility calculation spreadsheet and guide. And the presentation will be carried out by Mr. Niels Bech Larsen from Plan Energy. So the floor is yours, Mr. Niels Bech Larsen, for 10 minutes. Thank you.
Thank you, Laura. As you said, it will be a short presentation of a small spreadsheet for pre-feasibility calculation of heat pumps. And it's tool number 5. And it basically looks like this, where you, in the upper corner here, you can select the location, and it's the same location as the front runners, and you can choose your language. And the next you have to do is give the input required, heat demand, the share of the heat demand that are degree dependent, forward and return temperature. It's not in practice used, but there's also, beside the technologies, heat pump technologies and the other technologies included, there's a small solar that you can increase in size. You have to define and name your cheapest production unit and give the heat price for the production unit, and second cheapest and the peak load. And that's actually what is required to get this kind of duration curve that you have when you make your simulation. You then defined your heat pump, and for that we have, of course, make the tool. And for all the small blue numbers you saw before, there's an introduction to the different values, and you can see here there's an indicator for whether it's suitable or not. Giving the last input, you get the output, and what you saw before on the diagrams, you can of course also have in form of values. And of course, the most important thing is actually to make the economic calculations of production cost from the heat pump. And in this example here, we have 26.8 euro per megawatt hour heat produced. And I think the figures here give a better idea of what it's doing. You can see the influence of the outside temperature is increased or included in the calculation. So the capacity of the heat pump is lower during winter time compared to summertime. And if you have nothing new on this one. And basically on this screen, you have both the input and the outputs from the calculation. If you change some of the conditions, for instance, if the cheapest production units have a lower price compared to the heat pump, of course, it's not in use as a base load, but will be the second units used to get the cheapest production. It would be the second unit to produce. In the tool, we have, as I said before, the temperature levels for the locations for the front runners, so it can be actually used at these locations not with the this year temperatures, but with temperatures from 2023, and also solar data are integrated, but in principle not in use at the moment. And the way they have been downloaded is through Energy Pro, where there's a feature of getting meteorological data from basically all over the world, I believe. And here again, you see the annual variation of these inputs. And another thing to mention too is where to get the cost price for the technologies. And for that, we have used our own experience and of course also the Danish Energy Agency Technology Data Catalog. And what you can get there is actually investment cost, operating and maintenance, and a huge number of figures for the different technologies. And that we have actually tried to compare with our own experience, where you can see on the oops, disappeared. All the yellow values are from the catalog, and all the other smaller ones are actually based on our own experience from different heat pumps setups. One of the key things is one of the keys beside the investment costs is the COP, the energy efficiency of the heat pump. As you can see, there's a huge difference in the one we have registered and also what is expected from the Danish Energy Agency, depending on the size of the technologies. So the conclusion of this is that you actually have a small, easy to use tool to make a pre-feasibility calculations of heat pumps. And it compared to what you have of production technologies today. To illustrate how heat pumps are working, I have taken this example from Sæby, a small city in the northern part of Denmark. And this is 14 days in July. And the heat pump is actually the green one here in the bottom. But because they have solar heating in Sæby, they don't use the heat pump that much during summertime. If it's in May, you have, of course, more production, but you still have the main production from the solar heater. In April, it's a different story. Here you have basically only heat production from the heat pump. That's not correct, but you add on what is required more than the capacity of the heat pump. And during March and February and January, you have basically the heat pump running all time. And then you supply with gas engines when you have high electricity prices, electrical boilers when you have low electricity prices. Yeah. End of story from heat pumps.
Many thanks for presenting the tool number 5 on pre-feasibility calculation spreadsheet and guide. And we will have the last tool to be presented also by Mr. Niels Beck Larsen from Plan Energy on energy pro calculation examples. So the floor is yours again, and you have 10 minutes. And also just a quick reminder for all participants, feel free to ask questions in the questions and answers section.
Yeah, thank you, Laura. No, Rita, sorry. And this is a table of content of this presentation. As you can see, it's a mix of something from Energy Pro and a number of things from Excel, because that's the unique thing with this tool is you're using them basically together. And there's developed a guide for the tool. And if you have the conclusion first, you have now a possibility to have more detailed feasibility calculations with heat pump and compare it with other decarbonizing technologies. And to illustrate the use of the tool, there are defined 5 Excel sheets that match with 5 Energy Pro files. And the tool are calculating and presenting the thresholds for criteria for efficient district heating and cooling as described in the Energy Efficiency Directive Article 26. When you have defined your Energy Pro files, you take the standard reports from Energy Pro: cash flow, energy conversion, catalog of economic assumptions, and catalog of technical assumptions, and the environmental annual reports, and take them into Excel, and you have your results. Do never ever use the files online. Download the Energy Pro and Excel files and try to avoid SharePoint, because some of the links between the different Excel sheets are not working very well. When you should tailor-made it to your own condition, adjust energy prices to country and location, adjust climatic condition. If you have Energy Pro, you can find them in there. Define the plants that are active. Don't delete anything, because it's required that you have all the plants in the files, so the links between Excel and Energy Pro are intact. 5 scenarios are defined, where you have scenario 4, where you have all plants active. Scenario 3, you exclude waste to energy plants. Scenario 2, you exclude surplus heat, and in scenario 1, you exclude wood chip CHP plant, the wood chip CHP plant. So in scenario 1, you have the heat pump as base load. Download, as I said, the files. And when you have included the different reports, you will automatically get the capacity of the in the different scenarios. For instance, in scenario 1, you have no surplus heat capacity, you have no wood chip CHP plant, you have a heat pump, ammonia heat pump with 11 megawatt, and so on. And to get the costs and operating and maintenance figures, we have directly taken the Danish technology data catalog and use that for the economic calculations. Make your Energy Pro calculations, copy the data from the different reports to the clipboard, and integrate them in the Excel report. The Energy Pro file optimize the production, and it's use the net production cost, and actually it's possible to include or exclude the different cost elements that are predefined. And that's, of course, an important issue to do. And if you take it in version 4.9 of Energy Pro, its only way to see an overview is actually to go into the individual cost element and have a look whether it's included or not. But in Energy Pro 5, you have an overview of what kind of cost element that are included in the optimization. When you have done that, you have here the heat duration curve, or the duration curve for scenario 1, where you can see the heat pump as a base load, and its capacity decrease when the outdoor temperature decrease, and therefore you can see the share of the production from the heat pump is lower during winter time than it is during summertime. And you have the different scenarios. And if you have this heat duration curve, you can, of course, from Energy Pro also have this annual variation of the heat pump. All the results you can see in different ways in your overview file, where you're comparing the different scenarios. There's a number of different ways to present the results, including this donut picture that I have never used before, but actually I think it gives more or less the same values as these 4 diagrams, the normal circle diagrams, but it's actually included in one figure. And you can make similar things for both the heat production and for the cost. And as you can see here, when you have integrated waste CHP plant, that is basically the cheapest technology if you exclude tax and things like that. And you can see how big share of the production and the cost of the total production cost, because that's what is done for all units with all the 6 cost elements: operation and maintenance, fuel, tax, environmental, electricity sale, and capital costs that are included for all the element and integrated in this. Based on the cash flow report, you make that kind of calculations. And you have also the energy report that you need to include the economical precondition, technical conditions, where you have see here an example of how an heat pump are integrated with guarantee data for the heat pump delivered to the specific location. And last, the environmental report, where based on the values from that, you can make the comparison and calculate the threshold for energy efficiency or for efficient district heating and cooling as required in Article 26. You have different ways of presenting the cost in the scenarios, and this I would call it new way of showing how the average production costs are divided for the different technologies. I believe I have to do it rather quick here. In the overview Excel, you have the option of calculating internal rate of return and what other kind of comparison values for the different scenarios. And if you use only the cost of natural gas and your reference is natural gas boilers, then it's extremely difficult to get high internal rate of return with the new technologies. Are you included Danish tax on natural gas? It's much easier, and basically more or less all the technologies are cost efficient. So again, the conclusions as we started, no need to take them again. So end of story from tool 6.
Many thanks for Mr. Niels Beck Larsen for presenting the tools. So we have reached the end of our webinar. Many thanks for joining it. I think the interest is very high. We had 83 participants, and now at the end, the number is a little bit decreasing, but it was still 70. So many thanks for staying until the end. I'm checking the questions and answers field. There are no questions, but I think the reason for that is that there is much food for thought and many different tools and insights. So feel free also after the event to reach out to our project. I also would like to thank Euroheat and Power for making this webinar happen. So specifically Ms. Laura Yunasova, who is a senior project officer at Euroheat and Power, as well as Tadi Morris and the entire events team of the Europe Heat and Power. Also, I would like to thank all the speakers who are also excellent project partners of the SupportDHC project and other EU projects. We have excellent collaboration here. And also just to mention that this webinar has been recorded. So you don't have to worry that you don't remember everything. You can check it. It will be available on the Replication Hub website, as well as on the YouTube channel of the Euroheat and Power under the SupportDHC project section. So all is available for you. And yes, having said that, I would like to thank you again for your time. And I am just sending the link. I just got the link, which I can add or try to add in the question and answers section, because I think I also cannot include anything, unfortunately. We wanted, the idea was to place the link in the question and answers section as well. Maybe we could ask for some technical help for making this happen, because I also cannot post anything. It's not possible to post it, I'm sorry, but the link is www.replicationhub.supportdhc.eu. I think if you also just Google also SupportDHC Replication Hub, you will be able to find it. And yes, as mentioned, all the materials will be available also online. Many thanks for your attention.